Good day, esteemed researchers and curious minds tuning in from around the world. We're diving into the fascinating world of self-rewarding language models today. This groundbreaking research explores the potential of iterative training and self-instruction creation to enhance instruction following and reward modeling in language models. Prepare to delve into the intricacies of this approach, its evaluation against various benchmarks, and the intriguing insights it offers. Let's embark on this intellectual journey together. The primary aim of this research is to enhance instruction following and reward modeling in language models, building upon existing models and approaches. Our proposed method involves the use of Llama 2 Chat 70B for generating new prompts, employing a unique 8-shot prompting approach and specific decoding parameters t equals 0.6, p equals 0.9. In terms of evaluation, we utilized GPT-4 over multiple test prompts, employed the AlpacaEval 2.0 leaderboard format, and tested on a set of 9 NLP benchmarks. The results of our research indicate that iterative training improves instruction following and reward modeling. Interestingly, we also observed an increase in length in model generations. In essence, our work presents a significant step forward in the field of language models, demonstrating the potential of our proposed method in improving instruction following and reward modeling. Our research is driven by two primary objectives. First, we aim to enhance the ability of language models to follow instructions and generate high-quality responses. This involves not just understanding a user's request, but also crafting a response that is both helpful and harmless. Second, we are exploring the potential of iterative training and self-instruction creation. This involves the language model generating and evaluating its own instruction-following examples, which are then added to its training set. This process, which we refer to as self-instruction creation, allows the model to act as its own reward model, eliminating the need for an external one. The image you see here provides an overview of our method, the self-rewarding language models. This iterative approach allows each model to improve over the last, increasing the potential for self-improvement and removing a constraining bottleneck. This is a significant deviation from standard practices, and we believe it holds great promise for the future of language model training. Our research addresses a few key challenges in the field of language model training. Firstly, we aim to better understand the scaling laws of iterative training. This involves exploring how the effects of training change with more iterations and different language model capabilities. Secondly, we delve into the correlation between the length of model generations and their quality. This is a crucial aspect that needs further understanding, especially in the context of our results. Lastly, we investigate the possibility of reward hacking within our framework, a potential pitfall that requires careful analysis. The significance of our work lies in its potential to enhance both the performance and safety of language models. Previous solutions, while valuable, may not have fully tapped into the potential of iterative training, and the issue of length-quality correlation has not been adequately addressed. Our research aims to fill these gaps, providing new insights and methodologies in the field of language model training. Our research introduces a novel approach to instruction creation and following. We employ a fixed model, Llama 2 Chat 70B, to generate new prompts, using a method known as self-instruct. This involves sampling demonstrations from the IFT data and model-generated data, and applying various filtering techniques to ensure quality. In addition to prompt generation, we also utilize a self-rewarding model for generating responses and evaluating them. This model samples candidate responses and evaluates them multiple times to account for score variance, taking the average as the final result. To assess the performance of our models, we use GPT-4 to evaluate them over a variety of test prompts and NLP benchmarks. This rigorous evaluation process allows us to compare our models head-to-head and to compute their win rate against the baseline GPT-4 Turbo model. In summary, our research presents a comprehensive approach to instruction creation and following, combining innovative methods for prompt generation, response generation, and model evaluation. Our research introduces an iterative training approach with a unique twist on self-instruction creation. The aim is to enhance both instruction following and reward modeling capabilities in language models. Unlike traditional methods, we don't keep the reward model fixed. This deviation opens up the possibility for the model to improve itself over time. This innovative approach could potentially revolutionize how we train and improve language models. Our methodology employs a fixed model, Llama 2 Chat 70B, to generate new prompts. We utilize an 8-shot prompting approach, following the self-instruct method. The decoding parameters for prompt generation are set at t equals 0.6 and p equals 0.9. We apply the same prompt template and filtering techniques for non-classification tasks. The self-rewarding model is used in the creation pipeline for generating responses and evaluating them. We sample 4 candidate responses, with temperature T set at 0.7 and P at 0.9. To account for score variance, we generate evaluations multiple times and take the average. This comprehensive approach ensures the quality and relevance of our generated prompts and responses. In our research, we've taken a comprehensive approach to evaluate various models. We've used GPT-4 as an evaluator over a diverse set of 256 test prompts, and also over 805 prompts in the AlpacaEval 2.0 format. We've computed the win rate against the baseline GPT-4 Turbo model and tested the models on a wide array of 9 NLP benchmarks. Furthermore, we've graded the models on MT-Bench, a challenging set of multi-turn questions. Now let's talk about the innovations we've introduced. We've developed an iterative training approach and a unique method for self-instruction creation. The model acts as its own reward model, eliminating the need for an external one. This opens up a fascinating potential for the model to self-improve. These innovations mark a significant step forward in the field of AI research. Our research has yielded key results in 2 main areas. Firstly, we found that iterative training and self-instruction creation significantly enhanced both instruction following and reward modeling. This was accompanied by an increase in the length of model generations, suggesting more detailed responses. Importantly, we observed that the safety of the model potentially improved over time, allowing it to better handle challenging safety situations. Moving on to the implications of these results, they suggest that our approach can effectively enhance the performance of language models. The increased length of model generations not only indicates the model's ability to provide more detailed responses, but also opens up possibilities for a variety of applications. Furthermore, the potential improvement in safety over time is a promising development, as it reduces the risk of the model generating inappropriate or harmful content. Looking at the figure on the left, we can see the significant improvements in instruction following ability achieved through our novel approach. This approach, as we've discussed, enhances both instruction following and reward modeling. It does so by leveraging iterative training and the creation of self-instructions. This method has proven to be effective in our experiments, showing promising results in the field of AI training. The advancements we've made in this area open up new possibilities for more sophisticated and efficient AI models. Our proposed method leverages the Llama 2 Chat 70B model, employing specific decoding parameters and filtering techniques. The self-rewarding model plays a crucial role in generating and evaluating responses, with multiple evaluations conducted to ensure accuracy. In terms of evaluation, we utilized GPT-4 across a variety of test prompts. We also employed the AlpacaEval 2.0 leaderboard format and put our models to the test on 9 different NLP benchmarks. The results have been promising. We found that iterative training enhances both instruction following and reward modeling. We also observed an increase in the length of model generations. Interestingly, we foresee potential safety improvements over time with later iterations. This suggests that as the model learns and evolves, it could become better equipped to handle more challenging safety situations. Our research has led us to several key takeaways. Firstly, we found that iterative training and self-instruction creation can significantly enhance the performance of language models. This is a promising avenue for future research and development. Secondly, we've noticed a correlation between the length of model generations and their estimated quality. This intriguing relationship warrants further exploration to fully understand its implications. Lastly, our findings suggest that the safety of models could potentially improve over time. As the model's reward modeling ability improves with each training iteration, it may be better equipped to handle more complex safety situations. These insights pave the way for future advancements in language model training and evaluation.